Good morning, good afternoon, depending on where you are coming from. My name is Peter Zaitsev. I'm founder and CEO at SpearCorner, and I'm going to talk to you about a topic I'm very passionate about, is performance analysis and troubleshooting technologies for databases. I have just 20 minutes to cover a lot of material, so we just better get going. Now, if you've been in database space, you know what databases are often considered performance troublemakers from applications and the developer standpoint. And there is a good reason why. Because databases often have a non-linear scalability pattern, they are complex, and often they're also quite poorly understood by developers. Now, if you look at the databases overall, you have a number of tasks which you may need to perform around it. That may range from troubleshooting when your database is down, you need to take it up, capacity planning, making database to run fast in terms of cost and optimization standpoint, or change management, like looking at performance after upgrade your database or move to a different system. In a performance optimization point of view, we see there are two really different approaches you can take in a database. One is the black box approach. That is something which often database developer takes, right? And then there is a white box approach, which is something which more of DBA or DBA takes. What is the difference between those two approaches? From development point of view, the database is really a black box, where pure black box approach would mean what, as developer, you will have database as something you can connect on, you execute the queries, it responds quickly with correct result set, and that's all you care about. You don't really think about what is going on internally and why it is slow or fast. If you are more intimate with database from an operation point of view, you always often have to look at much more internals. You look at the load the database is handling, maybe resource optimizations, index usage, contention. There may be some system and hardware problems which may impact database performance and uptime at a point of view, and so on and so forth. Right? You kind of go under the hood and figure out what is wrong. Now, wherever your point of view is, you often can benefit from having a specific methodologies, so you can really follow some systematic approach to deliver the outcomes you want. Now, unfortunately, if you look overall at what is the most commonly used methodology this way, is finding solution by the random Googling. Now, what is a problem with random Googling? Well, in fact, there is a lot of good advice on Google, and often you can find solutions out there. But unfortunately, there is also a lot of bad advice or outdated advice you'll find on Google. And following this random poking around is hard to assume outcome. It's also hard to train people to follow this methodology, and also very hard to automate, which is increasingly important for us, right? Making sure what we can have software to give us a solution or even fix systems automatically instead of human doing that. There are better ways, and we are going to discuss some of them today. I will cover the three methods or methodologies which I find particularly useful. None of them is actually developed specifically for the databases, but they are very usable for databases as well. First is use method, developed by Brendan Greb. And it is really developed to troubleshoot system performance issues, not specifically databases, and its goal is to be able to resolve 80% of the problems with 5% of the effort, meaning there are going to be some problems where use method will not be enough and you will have to do more complicated things, but it is useful for a lot of stuff. Also, you'll find a lot of checklists available by Grand and Bragg for with methods. What does the use method stands for? It actually can be described in just one sentence. For every resource, check utilization, saturation, and errors. Right? What do those terms mean in use terminology? Resource is pretty much corresponds to all the physical components. Utilization corresponds to the time that resource was busy doing productive work, and the saturation corresponds to the queue, how much work was available to what this resource couldn't get to. And obviously errors is count of errors and events. Here are example of resources which you may be thinking when you use the use method. Now, use method is also applicable to software, and then there are software resources apply. For example, in a software you may be thinking about the mutex logs or file descriptions or connections, which you also using and may run out of. What are the use method benefits? Well, it has a very proven track record. It's broadly applicable for databases and beyond, and have a detailed checklist list available. The downside of that, though, it really requires a good understanding of a system architecture, right? And also you need to have access to low-level resources to understand what is going on with them. And that may be hard to use in some of a modern as-a-service environment. For example, if you are running something like database as a service, then you may not have that ability to look into the very detailed mechanics of resource optimizations. Here is an example of a checklist for use method for Linux, which is available from Brandon Gregg's website, and it's only a very small sample. I just wanted to show what is available out there and what you can use. From Percona, to support our efforts of use method and database, we have built Percona monitoring and management tool. This is our purpose-built open source solution for monitoring the databases. And here are some of the graphs what you can use to get this tool. For example, you can see their CPU utilization and saturation metrics, memory, which is also a very important resource. You can track that, disk saturation and utilization, as well as more detailed information, such as, for example, how current disk performance relates to its average. You can also look at the MySQL and other databases to look at the information of inflow of the queries, as well as internal work which is being done, such as how many queries database crunches a second. When you think about the MySQL saturation, one of the best way to measure that is actually to look at how many threads are currently active, and the tool provides this information as well. Well, with that, let's move quickly to the next method I mentioned, which is the RED method. The RED method comes from the need to analyze microservices when we are focusing kind of on cattle, not pets. And we are not looking to look at every particular resource on every particular system, because that's may be hard, and also mapping of resources may be fluid, but we are going to look at the high-level outcomes. What RED method stands for is what for every service request we are going to check whether those parameters are within service level objective. Rate, error rate, and duration slash distribution or distribution of latency what it is. So that is method, if you can see, is interesting. What it does not really point out to some low-level resources. If you're looking at read methods as we apply that to databases, it often makes sense to look at it at the service level, right? Like wherever the given database responds appropriately on the given connection. You can also look at the individual database servers. You can apply it to a specific application users or even to given query types of transaction. For example, you can say, hey, my new order transaction is kind of slow and fails very quickly. That means there is a problem in that particular area of functionality. Now, one thing I like about Red is what that really maps very well to what developers care about. Remember what we started talking about. Developers care what they can connect to the database and run the queries they care about quickly and get a correct result, right? That is really very close to what Record is about. It does not require us understanding the architecture very deeply and does not require a low-level access to resource monitoring. The problem with the Red method, though, is what the tools and checklists are less developed compared to the use method, and also I think Red method is focused more on what rather than why. You can figure out and say, well, you know what, this given new order transaction is failing 25% of the time, and this is wrong. Now we need to go and figure it out. We do understand at this point what that is, that given transaction which is failing, right? And that allows us to narrow our investigation, but that doesn't really directly answer a question why. In this case, for PMM, we also provide a lot of views which support answering those questions, both in a different views from the query analytic dashboards, as well as we have a current custom dashboards which really put that in the Red method terminology, looking at the query rate, errors rate, and latency and distribution. Now let's look at the last one, called the golden signals, so 4 golden signals. This really comes from the Monitoring Distributed System chapter in SRE book, and it can be used for alerting, for troubleshooting, for the trend analysis. It is not even positioned quite as a methodology, but I think it comes close enough to include that in this presentation. So what are those golden signals? One is latency. Right? As we discussed, well, that is really what a lot of developers care about. Then traffic, how much demand is placed on the system, right? How many queries are coming in, because, well, obviously if you have too many queries, then they tend to become slow. Errors, that can be error codes which are easily or incorrect responses, which are much harder to catch. And then there is a saturation, which is how full is your system compared to its capacity, right? How much it can handle. If you look at those signals, typically you will be able to get a good pointer of where your problems happen. Now, if you look at the golden signals for the databases, how do we apply that? Latency corresponds to a query response time by database instance or by query type, by user. Some of the graphs I just showed you a couple of minutes ago. In terms of traffic, that is inflow, number of queries of specific type served. Errors would correspond to connection failures and query error codes. That is typically what we focus on, as I mentioned, figuring out what the query response was wrong is quite hard and often is caught in the testing rather than in production. And from saturation standpoint, you can think about how much load database can take, about throughput for given type of queries, as well as other kind of saturations, like number of used connections versus mask connections, or the disk space versus how much space is available. Because when you run out of those resources, well, guess what, right? Database will stop to function, or at least some users would not be able to service. What are the benefits of a golden signals methodology? Well, that methodology is now very well tested by SREs or database reliability engineers as well. There are good books, and there are actually many resources online specifically for those methods. If you look at the drawbacks, it is framework for monitoring first of all, not for solving the troubleshooting. And same as for red methods, we don't have as detailed troubleshooting checklist developed as well. Now, to finish up, here are some simple meta takeaways. If you think at what exists in the space for troubleshooting database, there are actually multiple methodologies available. And I would suggest you to pick what makes sense for your circumstances and what you're most happy with. Or, frankly, you can even invent your own method combining those and other methods, which I know many people do, because none of them, frankly, can solve every single problem in every situation. Just my encouragement to you is to approach this problem systematically and not to settle for random Googling. That's all I have. Thank you.